Hello. Okay. Hello. Okay. Good afternoon, everyone. So I hope my screen is visible to you all. Now, I think there was some glitch with Tarun. My screen is visible and my voice is audible to you. Okay. Okay. Actually, there was some glitch with the audio and video. So most probably it has been solved. In between, if there is some more glitch, then just inform me in the this chat box so that I can get solve this issue. Okay. So let's start. Already it's 3:16. Okay. So we will start with the recap of this session, the weekly lectures, and then we'll solve some assignment questions, and then we will have your discussion and doubts if there are any questions from the previous session. So I encourage you guys to please ask your question if there are any question from the previous run or anything which you want to ask. So feel free to ask. Okay, share my slides. Okay. So once again, good afternoon, everyone, to this live NPTEL session. This is environmental impact assessment being taught by Professor Harshit Sosan Latra. He is assistant professor in Department of Architecture and Planning. And I am Rohit. I am a PMRF scholar at IIT Bombay, and I will be taking this live interaction session. So if there is anything which you want to ask, please feel free to ask. Okay, I always encourage asking questions. The live session teaching methodology is same. We will meet every Sunday from 3 to 5 p.m. Until unless there are some work and so the session is preponed or postponed. Okay. So basically, you can always ask your questions in discussion forum, or you can ask it now in the chat box also. Okay. So before going to the air pollution, let's see what is being taught in the lectures, and then we will have a good understanding about what constitute of air pollution. Okay. So basically, if you see, the first slide was basically taken from UN Environment Program. Okay. So drivers of environmental change. So how does environmental change actually occurs? So basically, one driver is population growth and demographics. So how population grows? Because when you have change in the population and demographic, then all the things are interconnected. So related things are also changed, like kind of standards of living change, economic development is change. Okay, urbanization, economic development, new technological forces. Okay, like something which is less polluting, more polluting. Okay, and climate change is always an issue. After industrial revolution, the kind of carbon which we have put in the environment, the global environment, that is the thing which need to be very sincerely solved. Okay, the problem is that when this carbon, the best thing which you can do is, to carbon is to convert it to CO2, but the CO2 itself is a global greenhouse gas. Okay, so that has to be taken care of. Second is human activities that generate emissions. So there are a lot of human activities, not apart from this, like emissions from nuclear energy. So nuclear energy is kind of clean fuel. So I will say emission from coal power plants are much more than nuclear energy, but still nuclear energy also has some additional auxiliary processes that also needs some kind of emissions that contribute to some kind of emissions. Also, radioactive emission is a kind of emission that is very different from what we imagine as air pollution, but still has some health hazard on human development. Uh, not human development, human health. Okay. Emission from industries and plant, that is very much well known. Emission from transportation, emission from waste management is also a big emission source that is now coming up, because one thing which we were talking about is population growth. So with population growth, the kind of waste which we are generating also increases. the quantum waste. And waste is basically stored in landfill sites or open dumps. So there are a lot of gases which are generated when these waste actually degrade due to the microbial actions. Okay, so you can read more about this emission from waste management, what type of emission are there in the landfill sites, how they are managed, how you can manage it, how to solve this type of issues. Okay. Another thing is that apart from this, I am also saying one emission is also there. Can anyone of you uh, look into it or say which other emission apart from these four? Anyone who wants to answer? So, am I audible to you all? Yes. Okay, Tarun, can you think of any emission apart from like emission from plants, coal power plants, emission from vehicles, emission from waste? Apart from that, okay, let me give you an example then. Emission from crops. Okay, so read about this. Rice fields, agricultural waste is another thing. Even when you plant crops also, they also contribute to some kind of emissions. Okay, so you can read about it. This is not a very big factor as of now, but still they contribute, like rice plantation also contributes to emission, like methane emissions are there also. Another thing is like emission from livestock. Okay, that you can also see by yourself also, like like gobar, uh, cow dung. So that also contributes to emission from livestock, because they also have methane generated in their body, which also has the emission potential. The potential is still low, but yeah, they also contribute to emission. Okay, so where we additional vehicular emission due to fringe area development. So fringe area development is basically kind of development which is not very much into the city limits. So fringe on the boundaries. So you see, when there is a city, then like every city has some fringe area, and then because the roads infrastructure are not so developed, so clogging, idle emissions, all these emissions also contribute a lot to the vehicular emission. Okay, so if a vehicle is flying on a highway and if a vehicle is in city limits, you see there is a lot of difference between the emission which is generated by the vehicle. Okay, so a lot of things also help in, like congestion, traffic congestion also contribute to the emission. Pollution due to construction activity. So this I don't want to explain because this is self-explanatory. Construction activity, PM emission is very much due to construction activity, not CO2, CH4, not these type of emission, particulate matter emission. So dust particles, okay, dust particles are very small, 2.5, 10. So they are very much generated during construction activities, and even if you are following the newspapers, you will see that Delhi has got a lot of these type of pollutions. Okay, and then ambitious open cast air mining, because that's an open cast mine, totally open from upside. So whenever you are going, see, you can see the dust here also, dust particles. So if you are if your hometown is near a mine or something, so you'll see the deposition of dust particles on your clothes also, on your skin also. When you wash your face, you will see some dust particles. So these also contribute a lot to the construction emissions. Okay, now definition and concepts of air pollution. So effects of air pollution on health. This is quite okay. I think everyone is knowing the effects of air pollution on health, because the major effect on human health, because it actually contributes to the lungs problem, basically COPD, asthma. It actually also cause comorbidity. Comorbidity is something that you have a illness by yourself. You have a pre-existing illness, and due to the air pollution, the kind of illness which you have becomes severe or worse. Okay, that is also a kind of comorbidity which air pollution basically introduces in your body. So if you see the data from World Health Organization, that basically contributes to 7 million deaths. Okay, 7 million is too much due to air pollution every year. 7 million is 70 lakh people are dying because of outdoor and indoor air pollution. This is data from World Health Organization. You can see the kind of people which are dying due to air pollution. And they have classified air pollution as a major environmental risk to health. And basically, they have basically said that stroke, heart disease, lung, and they are very much related to air pollution. Okay, and they've also given a data that how much is being contributed by which region also. So you can see it here. Okay, India is quite dark. Over 2 million people are affected. India and basically this ASEAN region, you can say India plus ASEAN, contributing to over 2 million. 2 million, too much. Okay. Now, air pollution impacts on natural and built environment. So basically, you can see one is kind of acid rain. If you have seen sulfur dioxide, nitrogen dioxide, basically goes into the atmosphere and then react with the water molecules and contribute to the acid rain. And that acid rain basically cause a lot of damage. They basically make the soil acidic. They damage the monuments. They damage the crops. They make the increase the cost of agriculture also, because you need to put more fertilizer, all these things. Okay, they also affect the marine life, also pollute rivers, streams, all these things happen. Then there is a lot of there on the this trees also. Basically they deposit on the tree surface, then they clog the stomata, and the plant, basically the leaf dies due to that. Okay, plant does not get the nutrients also. And basically they have defined it, basically air pollutants critical levels, so concentration of pollutants in the atmosphere above which that adverse impacts on receptors are basically who are recepting these pollutants, like human beings, plant, ecosystem, material may occur according to present knowledge. They have defined classified critical levels, critical loads, so you can go through these type of definitions. Then odor causes, so basically air pollution kind of one thing. Second thing is odor. So if your house is nearby, or maybe if you have read some stories about Delhi landfills, Balsawa landfill, Gazipur landfills, so you could have seen that the residents there are protesting a lot about this type of landfills. Basically, why they are protesting? Because the kind of smell they are these landfills are generating, these are making the lives of the residents very difficult. They are just like uh, they can't do anything much about this smell, and that's a kind of a new type of pollution which is being introduced. Okay, so order, basically, so which are basically these type of origin of order. So you can see if you are looking for hydrocarbon fuel, petrol, bitumen tar, diesel. So many of you say that petrol is a very good smelling, but petrol is very good smelling because a compound is mixed into the petrol to make it smell good. Okay, like cooking, animal origin is there, rotting, putrid, burnt, smoky, chemical solvent. All these have caused smell. Okay, so these are actually measured in Fidel units. Okay, Fidel factors. So Fidel basically means F is frequency. How frequent is the order detected? Is it continuously, daily? How is the frequency? Intensity. Okay, is it weak order? Is it strong order? Then duration. How long the duration lasts? Seconds, minutes, hours. Like if you put a perfume on your body, so duration is there always. Order is there. Order is with the perfume, and duration is there, like 2 hours. After 2 hours the order of perfume is fade. Offensiveness, how pleasant is the order, that is also an important. Location, where was the order experienced, home, business. Okay, so Fidel factors, so there can be questions in the exam from this also. Then there are guidelines, quality guidelines. So basically if you see WHO global air quality guidelines, so they have make it strict every year. So you can say for NO2, you can see in 2005 it was 40 micrograms per meter cube, but now it is 10 micrograms per meter cube. Similarly, PM 2.5, 10, and ozone also. So for ozone, they haven't changed much because ozone is actually kind of contributing to the ozone layer also. Okay, They are in the ground level. Ozone is very pollutant. Okay, ozone is a pollutant gas, but not at the upper atmospheric level. It prevents the UV rays from entering the earth and then preventing the cancer, actually, to a skin cancer based to a high level. Okay, then there are performance standards which we have seen in the last class also, like what are the labor performance standard, risk management standards. Okay, then India has also developed their ambient air quality standard. Earlier this was WHO, this was for India. You can see for India sulfur dioxide limits are, for industrial region it is 50 micrograms per meter cube. How much is this? Oh, they haven't given sulfur dioxide limits. So let's check it for nitrogen dioxide. It's annual 40. So 40. So 10 now. Okay. So India is quite relaxed compared to the WHO standard. The reason for relaxed is kind of technology we don't have at this level. Technological advancement takes time. Okay, so and also these technologies are very costly. Kind of these are developed by the specific companies in the developed world, so they charge a lot. So until unless we get to that level, we need to protect our industries. So if we put a lot of pressure on our industry, no, you have to follow this standard. So ultimately, this industry will shut down somehow, and then that will also affect the employment opportunities. So that's why India has somewhat relaxed standard, but doesn't mean that India doesn't have strict standards. Most of our vehicle standards are as strict as European standard, even much more stricter than European standards. Similarly for core power plants also, so that you need to look into. Okay, critical levels you can see. Order guidelines are there. Basically order guidelines are measured in OUE, European order units. Okay, the threshold by whereby 50% of the members of an order panel can detect an order in laboratory conditions. That is OUE. And you can see the order impact values in OUE. So this is red. Red is basically they are experiencing a very high order. Yellow is medium. Green is okay. This type. This is okay. EHS. There are a lot of EHS guidelines, so you can read about it. I think I need not explain each and every guidelines. And then if you want to go into this guidelines, so you can also visit the CPCB website. They contain a lot of guidelines which you can see and then look into. And basically scoping. So basically, what are the different air pollutants which you are looking into? So first is carbon monoxide. Carbon monoxide is generated when there is partial combustion of fuel. Carbon dioxide is there, nitrogen oxides are there, NOx to be precisely. Sulfur dioxide is there, ammonia is there, volatile organic compounds are there. Okay, so read about them. Ozone are there, persistent organic pollutants are there, particulate matter and heavy metals. Okay, they are basically polluted through the air pollution. So you can see sources of nitrogen dioxide, sulfur dioxide. You can see the sources for all these things. Okay, and for odor, these are the sources. Basically paint works create a lot of odor. Then I will rate it landfill processing food, especially the cooked food waste. They create a lot of odor because basically methane genetic bacteria was on this H2S, methane, all these things are very bad odor. Okay, construction activities, I won't say a lot of order is there, but yeah, because it's the construction activity, a lot of things are going on. So yeah, manure plants, order from landfill sites are not mentioned here, so they also create a lot of work. Okay, and these are the different agencies worldwide which basically create the pollution monitoring data. Okay, similarly, you can also access the data. They are actually available for Indian cities. Data. Prepared to measure air pollution concentration are based on. So basically, intended use of the data. So what are you going to do with the data? If it is CO2 data, what you are going to do? So generally, you will going to calculate GHG emission. But if it's a PM emission, particulate matter, so what you are going to do with that? Okay, consideration, the passive diffuser tubes. A simple, inexpensive device intended to measure high concentration of gaseous pollutants in the workplace over hours. So these are passive diffusion tubes. Okay, diffusion direction there, high concentration, low concentration there. So basically, these particles move into passive diffusion tubes. Pollution bioindicators. So these are also bioindicators, which basically bioindicators are something which are basically affected by the pollution, and then they show that. So lichens are basically a bioindicator for SOx. Okay, so if lichens are more than SOx is less, similar type of thing you can expect. Okay, black fungus is there. Baseline pollution, baseline is I think I have basically explained the baseline thing a lot of time. Okay, pollution inventory. So this slide is over. So if there is anything which you want to ask regarding this slide, you can generally ask. So this is a very good slide on the air pollution. Okay. Tarun Kumar has said is Sonendu has a question. Okay, so before that, is EIA not applied to landfill area? So there is a classification, Tarun. You can go and see that classification categories. If it fits into the category of EIA, then EIA is applied to landfill area also. So a whole notification is there. You can check into that. Okay. The screen is not showing in a correct way. Some problem in the screen. There is some. Is my screen visible to you all in correct way? Can anyone, Tarun? This one. So wasn't it visible properly? Now, then it will be not visible. Then okay, then you can adjust the zoom of your screen, because actually it will be very difficult. I don't know why this problem is happening here. Because of something. So let me share it again. Okay, don't worry. Setting entire screen. Okay. Is it okay now? Okay. I think that was problem with the screen sharing. Okay. Swanendu has a question. Yeah, Swanendu, go on. Ah, good afternoon. 24 hours. Exactly. Uh-huh. Okay. Okay, so okay, okay. So actually, what happens? Swanendu, first question is what is your question was? What are the immediate effects and why 24 hours average and annual average is given? That is your question. Okay, if I have understood correctly. Okay, so basically, what happens in case of air pollution? If you have remember, that's a very good question. I think you have asked a very good question. If you have remembered my slides earlier, I have said that key air pollution. If you have NOx concentration, NOx in the NOx, SOx, or CO2, anything, it is not a issue problem until unless the concentration is high. Okay, that is the issue. So first thing is that ki, why do we earlier have a smokestack, a big smokestack? Because it was all the pollutants. Earlier we didn't have any pollution control devices in our coal power plants. Okay, very मतलब NOx was controlled. Not SOx were never controlled in our coal power plants. Okay, the reason was all the pollutants were actually thrown out with a smokestack which has a very good height, I think 140 meter or something height. And what it happened, it dispersed down. So because of dispersal the concentration goes down. That's why the concentration is very important when we are talking about air pollution. Okay, first thing. Second thing is there are some immediate effects also, like if you will feel nausea if you are in going into high concentration zone. So you are going to face nausea, some respiratory problem also, difficulty in breathing. All these things can happen, but long term effects are much more having a much broader impact on our health. Like nausea is good. Okay, we are having nausea, that is okay. We can treat it again. Just wash your face, go to something having. But if you are having lung cancer or COPD, asthma, that has a very permanent impact due to air pollution. That is why long-term effects are more focused into in case of air pollution. Okay, because in general, what happens? Air pollution generally doesn't show a very short-term effect in. Okay, doesn't show a effect in very short duration. It does show a duration impact on a very long duration. Okay, effect. Now coming to the concentration unit, what happens? Ki these concentration units are not like ki you are just point source of air pollution is there, then it is going for 5 minutes, then you are going to measure for 5 minutes, then after 5 minutes, uh, these are standards for like coal power plants where the smoke is all coming throughout the day. Okay, so throughout the day, they have given that during a day, you cannot have this much quantity of smoke from the air stack, and annually you cannot have this much amount of air pollution from the stack. These are for industrial units. Okay. Now you are going to have it in what you say, like excavator or something which you said, black smoke comes. There are standards for that on also, but air pollution standards are not applied. Their vehicular pollution standards are applied. Okay, so there, if you, I will say, ARAI, Automotive uh, Regulatory Authority of India. This is in Pune. You will read the report of ARAI. They have specifically mentioned these standards, vehicular emission standards. So you can go there. They have given it for HC, NOx, SOx, everything. So they are measured according to that only. Okay. So there are standards for that vehicular emission also. Is it clear?
Yes, sir. Yes, sir.
Okay. So don't worry. If there is a pollution, there are standards, there are methods to measure that also. It is not like these basically these the standard which I saw. These are for general ambient atmosphere. NAAQS, National Ambient Air Quality Standards. It is not vehicular quality standards. Okay, that is from different institute in India, which basically publish the. You can see the emission factor for vehicles also. Okay. हाँ. Okay. Exactly. Exactly. Mm-hmm. Basically, these guidelines are actually for the. हाँ. Mm. I agree. Exactly. So that's called a transboundary air pollution. That is already there are standards for that also. Okay. So basically, what happens? Air pollution is like there are basically Gaussian distribution in the air. When you are studying the air pollution, so if there is a point source in Bhopal, so generally what happens? There is very least probability that that point source is going to affect someone in Kolkata. Not on the sense of, but in like you said, ki, no sir, for a big year, if there is a pollution, yeah, certainly there will be like a greenhouse gas effect which will be felt in Kolkata, acid rain effect which will be felt in Kolkata. So yeah, certainly there will be some effect, and so that's why there are standards. These standards are for measurements. Okay, if you are measuring something, so this is the standard. If it is more than that, then that is polluting. Okay, so you can see, if I show you the standard, it is not per day. We're confusing it with per day actually. Standards. Okay, so you can see annual mean. So when you look at it very clearly, I am saying it for NOx. Yeah. Yeah. Is it okay? Okay. This is annual mean, means annual mean, and it is measured per meter cube of gas. It is not measured per day or per time. Okay. So annual mean they have taken per meter cube for 365 days, and they are giving it as a mean. If it is more than this, then it is a pollution. And on any day, okay, on any day you cannot have more than 75 microgram per meter cube. So this is what these annual mean and 24-hour mean represent. It doesn't mean okay, 75 microgram per day. It is per meter cube of gas which is emitted. Okay, now your point is clear. So any pollution which is emitting in Bhopal or Mumbai, that is certainly going to affect Kolkata resident someday or other. Okay, that is why everyone. Uh-huh. Should I put the screen? Uh, That will consider as a air pollution. Exactly. Uh, this is a UK standard, na? This is a UK standard. They are way ahead of us. This is a UK standard actually. NAQS standards are. I think this is kind of this is NAQS standard, and not to 20 microgram per meter cube. Okay, so they have given it for, you can see, air quality of Kolkata. They have given it for these 3 years. Okay, this is NAQS. So you can see, this is not okay. This is not okay. So every year NO2 pollution is more than 20. So every year the plant is monitoring. Sorry, plant is polluting. Okay. I hope that's clear. That makes your point clear. Sometimes actually, what happens on Endo, I will say actually what happens. These air quality standards are very strict in the case of India, and they have a proper methodology to calculate. Sometimes what they do, these power plants, they actually put oxygen into the flow, in the flue gases which is coming out, they put oxygen, they inject the oxygen, and because of the injection of the oxygen, the per meter cube flow is actually goes down, and they say no sir, no pollution is occurring to CPCB. So if you see the air quality standard, they have especially defined for 8% oxygen levels, this pollution has to. So these need to be calculated. Whatever they are reporting, these need to be calculated for 8% oxygen, and then has to be seen whether they are polluting or not. There are a lot of calculation. Basically, an environmental engineer can easily do that because they are trained into that. Okay, so okay. Anything else from that's a very good point, and that's a good question, I think. So Nandu has raised a lot of good points and question. Anyone else has any question? Okay, so let's solve the assignment questions. So what are the effects of air? My assignment is visible to you all. Slides are visible. Okay, so what are the effects of air pollutants? Cause inflammatory, sensitive, sensitize and scar the airways, can affect lungs. Done. Pollution can reside permanently in the body. Exactly. This can reside. Impact can vary from irritation, serious illness. So irritation are short-term effect. Serious illness, long-term effect, and then death, long-term effect. So 1, 2, 3, 4, all are correct. Now we'll see a very good documentary, I think, from the air pollution. Okay. So basically, you guys could see they have explained it very beautifully in this video that what constitute of air pollution, what is effect and everything. I think these type of videos you can also see in the YouTube. A lot of videos are there, especially from some of the good organization. They have uploaded the video. One video is I remember it from the Nat Geo, National Geographic. I was going through all the lectures and they have uploaded a very good video on I think climate change or something. Maybe I should have uh, maybe it is in the link is in the slide. If I could find, I will show you again. Okay, basically this we have done. Air pollution is basically pollution major public health concern. This you can this is from the this definition is from the W Health Organization. Air pollution is the contamination of indoor or outdoor environment by chemical, physical or biological agent that modifies the natural characteristic of the atmosphere. Okay, so this is the definition of air pollution. This is okay. Air pollution critical levels. Air pollution critical levels are defined as the concentration of pollutants in the atmosphere above which direct adverse effects on the receptors such as human beings, plant, ecosystem and material may occur according to the present knowledge. So this is a true statement. Okay. This is from the definition from UNECE, Economics and Cultural Council. I think these are from the standards. This is National Ambient Air Quality Standards (NAQS) by Government of India. Okay, by CPCB basically, and they have actually based how these can be measured. Actually, you can see it here. Okay, International Finance Corporation provides performance standards. One, it is an international benchmark for international social risk. Yeah, so you remember performance standard one was basically risk management. Performance standard two was labor. So this is a correct statement. You can see it here. Match the following types of impact prediction and evaluation models. So yeah, you can see Gaussian models. All these things are there. So basically, moving into the next slide. So before I move to the next slide, is there any question you want to ask from the slides? Okay, so let's have a break for 4 to 5 minutes and then we'll assemble again. So in this break, please go through whatever I have taught and whatever the assignments are there. And if there are any question, please feel free to ask. Okay. Hello. Okay, so we are back. Is there any questions which you guys want to ask? Did you went through the slides and did you find anything worth interesting or anything which you want to ask regarding the whatever was taught regarding the air pollution? Okay, so if there is nothing, then I think we can proceed for the next slide. I think I need to adjust the zoom. Okay, so basically, this in this slide we'll talk about the impact prediction and evaluation of different air pollution controls and different devices. Okay, one thing is physical scale model. So I think physical model which you can see generally if you have a building or something, if you are a civil engineer, you are more into these type of things. So basically, before building something, we make a model of that, a kind of physical model, not a simulation model. Generally, we make a model on simulation. Now, a lot of software like ANSYS, uh, console, all these things are there where you can go and have a simulation model also in the computer itself. But before that, we make like these type of models and then let's say we want to test it for wind. So wind is blown and then we check the different types of effect of wind. All these things are there. So expert opinion, predictive method important in the process, particularly at early stage of the project design. Important for any type of project, cost and time effective. Okay, expert opinion is kind of a one type of method. Numerical dispersion models. Through the model, basically you can calculate how specified emission rates are transformed by the atmospheric processes into pollution concentration at different senses from source or sources of the pollution. Okay, so basically what we want to do in case of numerical dispersion model, we generally let us we assume a point source from the smokestack of a chimney. Then that pollution will have a dispersion, it will disperse. The rate of dispersion, all these things are basically calculated, and then the amount is estimated, like how much will be the after 1 kilometer distance, how much will be the emission, how much will be the effect of the different devices, all these things. Okay, the pattern can vary with atmospheric processes of dilution, like if there is air flow. So all these things will certainly dilute it. Also can be transformed sometimes because of the chemical and photochemical processes. Like there are various specific parameters also in the atmosphere, not only wind or like sunlight is also a parameter. Different things are there, wind, speed, buildings, all these things. They actually modify. Models are also used to predicting pollution concentration for emission from a single point source and also from emission from a large point source simultaneously, like ponds, settling tanks. Okay. Settling tanks you will see in wastewater plants. Okay, sewage treatment plants, wastewater plants you will see settling tanks. Open cast mines, quarries. Okay. These are area sources, like construction sites are area sources. Why is it area sources? Because they are spread over a kind of large area. Traffic and car parks are area sources. Motorways, service station are area sources. Industrial vents are also area sources because in the kind of industry there is not a single vent. Okay, a lot of vents there. Okay, then we have line sources like open roads are there. So you get a pollution in case of in a straight line. There are line sources. Street canyons are there. Railways are there. You will see the pollution in line source. Then we have volume sources like leaking gas from a group of industrial processes is kind of a volume sources. Okay. Then we have aeroplane. Okay. Takeoff landing activities at an airport is a kind of volume sources because that a humongous amount of aircraft is going to land on it and a lot of aircrafts are there. They generate a lot of pollution and that all pollution goes into atmosphere. So it's kind of a 3D effect, kind of create a big volumetry effect. Okay, it is not a kind of a line sources only, like it is running on the runway only. The whole area is covered and kind of when it flies above the sky also you will see the pollution. So numerical dispersion models are of two types. One is simple screening model. Second one is complex advanced models. There are different software also for that. Like US EPA Screen 3 is kind of a one of the sources. software. So you need to identify the type of source, terrain option, which type of terrain option is there. Is it flat terrain? Is it a complex terrain, or simply elevated terrain is there? Similarly, all these things have to be selected, and then it basically says ki after this much, it basically gives the amount of pollution. Similarly, for air screen is also a kind of you say model which basically says about the dispersion of these pollutants in atmosphere. There are complex models also like CalPUF. So if you have an elevated train, then complex train, then again some factors is affecting there. Volumetric source is there. So yeah, CalPUF is there. AirMod is one of very good software for aero modeling dispersion models. Okay. Air quality standards. I don't look into CalPUF. Something looks like this if you open it. Okay. So the results are likely presented like this only. Models for impact prediction, like what are the different impacts. So someone has asked about like, sir, how can we say about the impact? So there are different models also which basically predict that, like ISCST2 is a model. The create for point area source. Okay, flat and rolling terrain can take up 99 sources, receptor elevation, so data. All these things you can go through these different models, and basically the kind of model which we are going to use is basically dependent on what are our requirements, what we are going to study. Okay. OCD, option and question disposal. So there are a lot of models you can read about these in this slide. Application remarks are there. I'm not going much into the detail because these are very simple slides which I think which you can, but there can be some questions. Some of the important models which I said about CalPUF, AeroMod is there. One thing is aero pollution dispersion modeling Gaussian model. So basically Gaussian model, what it does say that if there is smokestack, so you know if there is a coal power plant and there is a smokestack is there and the emission is coming out of the smokestack, the first question here is which type of source is this? Is it an area source? Is it a point source? Or is it a volume source? Anyone from the students want to answer this? The first thing which you need to identify which type of source is which source? Point source. Actually, Tarun, in case of industrial sources, these are generally, if you are considering only one smokestack, so that will be point source. But basically, in case of industrial or coal power plants, so there are a lot of smokestack are there. So these basically constitute of a area source. Okay. Okay, so in case of what happens, so it flows like this only, and Gaussian distribution flows like in the form of a Gaussian distribution where most of the particles are in between. You can see the probability distribution here, curve here. Most of the particles which you will be finding it here, and on the edge of this, verge of this, you will find the particles are getting reduced, and this is the whole thing is getting more breadth and the concentration are getting lowered on the edges and more in the middle channel. But after some time, because of the dispersion, this whole thing is dispersed into to the atmosphere, and basically there are various factors which also affect this dispersion, which we were discussed in the earlier slides also. Okay, and this goes into the direction of wind speed. So if wind speed is like this direction, though the whole thing will be shifted to that direction only. One thing is there are different types of air pollution dispersion modeling, like a fanning. This is fanning. Okay, stable. Coning is there. Lofting is there. Lofting is like lifting. So kind of this is the source, and it is going like this. Fumigating is basically fumes, making fumes. Okay. Looping is something like this. So these are type of plume dispersion are there, which you will see. And apart from this, there are formation of eddies also. So if air pollution is going to that direction, and you will have a Burj Khalifa in between. Oh no, Burj Khalifa is quite Burj Khalifa also. Or let's say a normal building is there in between. So these air pollution particles will form ADs, different type of ADs that will go into the. So that also make this whole thing complex. So complex software models are basically needed when you are going into these type of things. So there are basic various classification also line source models are there which you can use. Okay, road traffic for road traffic, modeling inputs, data requirement, emission data, meteorological data. What is meteorological data? Basically related to weather data. What will be the wind condition? What will be the temperature? All these things. And so these are meteorological data: wind speed, wind direction, dry bulb temperature, wet bulb temperature. See if any one of you knows the difference between dry bulb temperature and wet bulb temperature. So I will suggest you guys to read what is dry bulb temperature, what is wet bulb temperature, and why do we need to. This is very much related to humidity kind of thing. So read about this dry bulb temperature and wet. And if you are not getting or understanding what is the difference between two, please remind me in the next class. I will make it clear. But I certainly want you guys to look into it first. Very much related to how does these are. Basically, these temperature values are actually feed into the model. Okay, when you are going to like CalPUP modeling or air modeling, aero mod, these will be required. So basically, when you are selecting a date, so these data are actually taken itself from the different. So there are different database also. NREL database is there. All these databases there. So they take data automatically from that for that day only. Okay, relative humidity, rainfall, solar radiation, because all these things will affect the dispersion bonding. And this is a kind of meteorological data measurement instrument. So if you are from something like renewable engineering background or energy system, so on the roof of that building you will see these type of weather station. They call it weather station, built on the roof of this building. Okay, so this is humidity, this is temperature, this is energy sensor, like how much energy is falling into the surface. This is wind sensor. You will find wind direction and what is the wind speed. Okay. So natural air quality is much more needed. Terrain topography data is very much necessary. Okay. So basically, how much is the altitude? How much the altitude is varying? Okay. The plain area, all these things are important. Then predictive methods like risk-based assessment is there, semi-quantitative assessment is there, dispersion modeling is there. Okay, lot of things are there. Even the data in the some form is also given. We will link emission factor outputs for 250 building alternatives. Okay. Now let us move to the assignment questions. So numerical dispersion modeling is dispersion. This model considers the pollution emission spread outwards from a source expanding through aligned to the wind direction. So basically, it's the model calculator. Gaussian is basically first Gaussian spread outwards. No, R is one na expanding plume aligned to the wind direction. So if you remember this Gaussian, this Gaussian. In the wind direction, expanding plume. Okay, you can see R is 1, Q is 3 basically. Some behavior of pollutants in the atmosphere, they can be used to limited meteorological input data such as minimum maximum ambient air temperature. And P is basically 2. This model you can calculate specific emission transformed by atmospheric pollutants. So this is actually dot. Match the following order assessment effect models. Okay. So this is regarding the dispersion model. This was basically risk based assessment, order based assessment method. You can see it here. These are very, related to order, I think. Okay. risk-based assessment where we look at the pathway and the receptor and then we draw conclusion. Okay. Semi-quantitative assessment is basically look up tables to predict the order concentration. So these tables they are talking about. And then there is dispersion modeling, order concentration of predicted and compared to the benchmark values, which are accepted values, and we compare with that. So basically we predict the order concentration and then we compare it with benchmark value whether it is above or lower than the accepted values. So correct answer is P2 Q3 R1. ADMS, EPA, Cal3, Calin 4 modeling are used in different countries for road traffic. That is true. That we saw in the slides also here. Following match the following surface and groundwater quality determined by the following three classes of attributes. So let's see if we have a slide on this. Water assessment. So development activities affect the water budget. So what if you first thing is water budget? What is a water budget? What is the budget basically? So budget is basically whatever is incoming, whatever is outgoing, kind of accounting for all these things. So evapotranspiration is one thing, increase the runoff rate, reduce the infiltration, groundwater recharge, reduction in infiltration. Okay, flooding occurs where water courses do not have the capacity to transfer the surplus water which is generated. So this you can see impacts of dam construction, environmental flow requirements, hydroelectricity, sedimentation will happen in this area. So every dam this requires a lot of draining activities because the river carries sand particles with it and the flow is hampered. So all these sand particles are actually deposited here. Flooded habitat recreation, salinity, loss of livelihood for fisheries, transboundary water competition. Because like in case of Tista River or Brahmaputra River, Bangladesh is making a lot of noise that we are not getting water from India. Okay. Potential impact on river systems. This you can, I think, this doesn't need a lot of explanation from my side. Base flow, movement of water between surface body and groundwater referred to as base flow. Okay. Base flow contributes to the river flow varies significantly with the geological and topography of the catchment and with seawater. Return period or recurrence interval. Return period is most common way of showing the chances of the flow or rainfall event to occur. So basically, it is a statistical analysis based on there is a historical data, and then we say that based on this, we can say there are chances of flow of rainfall event to reoccur. Return period tells us the chances of the same flow of the rain increasing in a year. So return period is 1 by P, probability of accident. So for a 2-year return period, probability of accidents is 50%. Water budget is usually calculated for a period of time and are given in depth. They can be presented as a volume by multiplying the depth by surface area of the water share. So this is something like this. Like first thing precipitation, whatever rainfall is coming. Second thing is surface runoff, whatever is surface runoff which has happened. Then groundwater flow, whatever has gone to the ground, and then whatever has gone to the evapotranspiration, and then that will be represent the change in storage in the specific period time. So basically, rainfall precipitation data is important. Surface runoff is important. Runoff curves, curve developed from combination hydrological soil use. All these things are very much important. So this you can see recharge area, discharge area, day, years. You will see. Okay. Evapotranspiration consists of two things: transpiration and evaporation. So evapotranspiration is from the leaves of the trees, basically. So it is like a loss of water vapor from the surface of plant, basically from the leaves. And basically, one of the things which is contributed to the evapotranspiration is the evaporation of moisture from the soil and other sources such as lakes, river, oceans are also considered as evapotranspiration. And based on the soil and plant types, amount of potential evapotranspiration also varies because If you are considering alluvial soil or if you are considering small plants, so your evapotranspiration will be less. Sorry, alluvial soil, rocky soil, so your evapotranspiration will be less. Okay. Inputs required for estimation of precipitation, temperature, and latitude. These are very much required. Okay. Surface and groundwater quality. So basically, when you are talking of the quality, the quality can be of three types. So these are the slide which I am going to talk about is very much important. So please let's see if any question is there. Someone was and any question is there from anyone? Okay. So if there are no questions, then let me. So the slide upcoming slides are very much important. One is chemical attribute. Attributes are basically characteristics, physical, biological. So what are chemical attributes? They haven't talked about the chemical attributes here. So basically, when you talk, yeah, exactly. That is correct. BOD, CO, BOD is biological attributes. Chemical attributes are something like pH. All these things are chemical attributes. How much is the H plus ion in there in the physical attributes is like turbidity, okay, order. All these things are physical attributes. So we use the morphology. I think these things are really quite common. Dimensional stability, factor affecting the. So there can be question from these. So please look into these external controls and factors which affect the geomorphology. Okay, cohesive bedrock channel, non-cohesive sand bed channels. These are quite common. So these are basically matrix type table, which is basically checklist type method which you have seen in the earlier also. Okay, sources of fats, divergence, the change in hydrology, source pathway receptor model. The source of any effect is usually the specific development activity. The pathway is the mechanism by which the source can affect the receptor. Okay. Source is basically they have actually given what is source, what is path, meaning of pathway. The pathway basically is a mechanism. A source is basically any effect which is basically usually due to the development activity. Receptors are basically somewhere flora, fauna, all these things. Water quality. Hmm. These are slides which you can go into, and then most of things are self-explanatory because I don't think something which need to be explained very in detail. Typical social information, data for surface water. Okay, so research, sectioning, channelization, all these things are there. Being bank variable. Indirect source of the impact of water like roads, engine drainage systems, drawdown by dewatering and deep cutting, sediment loads from vehicles, road wear, erosion of cutting and embankments, pollution of the wastewater courses by organic content of silt other organics. Okay, urban and chemical development is there, industrial development. So there can be question in these are the different indirect source on the impact of water. Mineral exploitation, landfill, forestry. So USA had developed a hydrological, basically watershed model, HECHMS, hydrological engineering. So Australia has also developed a two-flow model. That is also good. UK had developed FESCD-ROM. Okay, hydrology, water flood, HWMM. So these there are different models for managing the water related quality. Basis. To the So these are different key property related to soil like texture. Okay, texture is kind of basically a morphology of soil. How does soil feel like? Okay, is it dry or is it affects the chemical physical property? Indicates the process of soil formation. Clay content. So clay content is basically when you are evaluating texture, it basically if you it does have a large clay content, then texture will be very smooth. Coarse fragments affects water storage and nutrient supply. So basically, if there it is coarse, fine soil holds more water or coarse soil holds more water. Which one holds more water? Anyone? Fine soil will hold more water or coarse soil will hold more water?
Sorry.
Fine soil. Are you sure? Coarse soil. Exactly. So fine soil basically not only surface area, it can actually absorb water on its surface. Coarse soil may have very difficulty in water storage actually. Bulk density, suitability for root growth, guide to permeability. So permeability is very important. How the water actually seep down through the soil. Uh, pH, control nutrient availability, and many chemical reactions indicate the degree of aging. How much should be the pH of soil for plant growth? Anyone? Should be between 6.5 to 8.5. Okay. That is pH of water. Okay. Water now for pH of water it is something around 6.5 to 8 or something or 7.5 something. Depth to A1, B2 impeding layer, thickness of soil and radius. Also this something related to water nutrients. Okay, humus, all these things. Volumetric water content is very important because it tells us about how much water can a soil retain. Water availability can make it available to the plants also. And available water capacity. Primary control on the molecular position. Conductivity is also very much important because conductivity, how much should be the conductivity of soil? It should be less than 4 centimeter, 4 Siemens per centimeter. Electrical conductivity, hydraulic conductivity, aggregate stability, because aggregate can also contribute because all these things basically make give a texture to the soil. That is very much important for the plant's growth. Because if it is only fine soil only, then what happens? The various fixation of nutrients will not happen from the atmosphere, and that is also very dangerous. Some of exchangeable basis, cation exchange capacity. So basically, it also indicates the degree of weathering. Okay, exchange sodium percentage, substrate type is there, substrate permeability is there, and these are different soil profile and classification. So first is C is parent rock. Of that alluvial rich in iron layer is there. Then orange alluvial margin horizon. Then black alluvial horizon. And alluvial bleached iron affidavit because iron will be leached to here this sublayer. In mineral mixed organic layers basically 1 to L2H. Dark reddish brown. This you can see soil profile oxysol. Okay, soil structure. The first thing is organic layer, which is called humus. Then comes the A topsoil. Okay, that is mineral plus organic matter. B is subsoil, that basically consists of sand, silt, and clay. Then C is substratum, that is parent rock. R is bedrock, unweathered parent nucleus. Okay, and the different soil colors are there: red soil, yellow soil, all these things are there. That basically tells us about the quality and health of the soil. Soil fertility, so low soil fertility and toxicity, low soil fertility due to either low level of nutrients or they are being made unavailable for plant uptake. And basically, soil toxicity can also be due to toxic element like heavy metals or not present in the soils. Land quality, I think, is a lot of things. For India, there is Geological Survey of India, which basically looks into the digital terrain models, data models. So this is the kind of a model which you can see for terrain. So these colors basically say about the different temperature heights. Okay, Aster is there, Geological Survey of India. So this you can see here. So there are two map types. One is solid maps, which basically show the pre-quaternary rocks. Okay. Then there are depth map, which basically show superficial quaternary deposits that have been laid down more recently by moving by wind, water, and ice. And there are desktop studies, data sources. So these are basically data sources which I can go and look into. Okay. And if a food and agriculture organization also has a soil portal that you can look in. And if you are looking into the impact prediction model on case of soil, so there are different impact like digital techniques are there, provide land use, ranking analysis for soil suitability criteria is there, affected microflora fauna. So all these things are there basically for the soil impact prediction. Okay. So there are different equations also, predictive equation like universal soil loss equation, wind erosion prediction system is there. And there are soil pollution also which is being talked into. So one is contamination of site, another one is pollution maybe due to the project itself. Then there are hydrological flow models which were there in the question. Okay, so this was the from the soil pollution, and then we'll move into the climate and all these things. So first is basically groundwater quality determined by assessing three classes of attributes. One is physical attributes. So that is basically natural water varies the amount of particulates present in them. Rivers typically carry large quantity. So basically talking about the particulates. So that is a physical parameter. Biological attributes is I know something microbiology or something virus bacteria. So microbiology. So this is the correct answer. What about pathogens? Okay. Chemical attributes, dissolved chemical solutes which originate from atmosphere, soil or weathering of bedrock. So correct answer is P2, Q3 and R1. State true or false water quality assessment test of study. So this is actually true statement. Okay. This you can see it here also. Cover large areas, whole country, regional map details. So P is a scale 1 is to 1 million, 1 is to 2 lakh 50,000 scale is basically over large areas. So because 1 is to 1 million, you can see that is used for large area or whole country. Regional maps are basically more focused into. So regional maps will be a scale 1 is to 10,000 and then details because going into details, so that will be basically scale 1 is to 20 million. Okay, so this is where you can get into. Field survey of land soil involves required to collect baseline information on land and soil from field survey. Information such as landform, soil types, land quality, ground cover, land cover, and tenure. GIS for special and statistical analysis. So current answer is 1, 2, and 3. Land swell for land swell, historical maps are not so important. This is from this slide. To estimate the soil pollution, two types of situation exist where in EIA site is already contaminated. That is true. Soil pollution may be caused by the polluted soil. That is also true. Greenhouse gases are gases constitute the atmosphere that absorb and emit radiation at a specific wavelength within the spectrum of infrared radiation emitted by Earth's surface. So this is a true statement. Okay. So this is greenhouse gas emission. Greenhouse gas emission is basically the air pollutants or pollutant that basically absorb the sun radiation. Actually make the earth warm. Okay, they produce the greenhouse gas effect. So water vapor, carbon dioxide, nitrogen dioxide, methane, ozone are primary greenhouse gases. Okay, nitrous oxide is actually it has a 280 times greenhouse gas effect than carbon CO2. And then mitigation, resilience, and climate change. So mitigation is basically anything activity or mechanism. No, human intervention to reduce this. So this is mitigation. A human intervention to reduce the sources or enhance the risk of greenhouse gases. Resilience is basically capacity of social, economic, and environmental system to cope with a hazardous event. So that is basically resilience. Like Japan has a good resilience for earthquakes. Okay. Climate change is basically any process or activity or mechanism that removes greenhouse gas. Because of no. This is the correct. Correct answer is answer A. Okay. One thing is that I wanted to show you guys a EIA report. This is how EIA report actually looks like. Okay. This is a kind of EIA report. Okay. If you have not seen an EIA report, this is your EIA report. This is submitted by one of the consultant named Consulting Engineer Associates in Panchkula, Chandigarh. Okay, so this you can see a kind of overview, details. It's a well prepared report submitted. First thing is introduction about the project, what is the background. Okay, all these things are actually you can see the details. The impacts are actually calculated. Different things are actually given. Okay, this is kind of a EIA report. And then we have all these things like EIA in India relevant documents you can read from here. Standard terms of reference I have given like in India terms of reference is very much important. These are guidance manual. All these things I compiled it. You can go and read into. Okay. And one thing is that I wanted to share one video on the change. That was very much important. There was one video from the Nat Geo, I think. So these are basically kind of two things which you can say. Thing is that these two videos, all these things, if you are seeing this National Geographic videos, they have provided a lot of things on the climate change, like what is global warming, what are all these things. So let's look into this. What are the effects of climate change? Human activities, pollution. that needs to be looked into, and these things are actually quite serious when you are looking about all these things as a whole concept when you are driving the climate change. And this is how basically how the things are actually going into, and basically to be looked into, and each and everything are basically contributing a lot to the climate change, like greenhouse gas emission from the air pollutant. Not only the greenhouse gas emissions, but various and greenhouse gas emission are basically one of the anthropological factors, but natural factors are also there that is basically contributing to the climate change. But after industrial revolution, the kind of greenhouse gas emission anthropological factors have affected the climate change. The climate change has shoot up actually. The temperature rise is actually increasing. If we go by this kind of this level of CO2 emission by the end of 21st century, it is predicted that 2%, 2 degrees Celsius will be the average temperature rise in the global temperature. So that need to be looked into. Okay. So, so again, thank you guys. Thank you for attending this live session. And if there are any questions, please feel free to reach out to me at this email ID. Okay. So thank you once again. If there are no question, you guys can actually leave, and I can close this session. Thank you. Welcome. Welcome, sir. Welcome, everybody. Okay.